Okay, this is my MATLAB app submission for my final project. Um, yeah, here it is. It's not really best looking, but works. So here we have our graph that'll graph the flow rate versus the pump head, because I kind of realized I needed to plot something after I submitted it, so just kind of threw that on there. I mean, it's cool to see the relationship between pump head and flow rate. Here we have our inputs. There is what? Three, math? 8 inputs that we can use. Let's see, it's a lot of inputs. We have a results window here. It's kind of fun to program in. So let's just run it. View what it should look like. Here we are. Let's see. So I guess the best way to show how it works, or to explain how it works, is just to do it. So here's an example that I ripped out of one of the previous homework assignments I had in my fluids class. So we have our data, or our givens. So our flow rate, that, fluid density. So what's my length? Some restraints I have on this software is that it's only in SI units. I didn't turn it over to um, customary or whatever the American system is. I could probably input like a button to um, like do like a button and then have it check to see the if it's in uh, American units or the SI units, and then have it convert or change up the equation to use this slightly or whatnot. Um, let's see. So basically, put in your inputs, and then when you run it, it'll go through a if. Yeah, it'll go through an if statement or a conditional to check if it's falls within um, turbulent or laminar flow to help determine what equation to use for our friction factor. Yeah, I can calculate. It'll give you relationship between pump head, flow rate. Flow rate itself is connected to, I have it as a vector from what is it, 1 to Q, which is the variable I define as flow rate, the code. So the max or the limit that it'll go to on the x-axis is whatever you put in here for flow rate. So as you change it, it'll change, extending this out farther. So I guess it's driven by an input. Pump head is also just derived from all these inputs and various equations. The results window displays here, gives you your Reynolds number, your friction factor, head loss, average velocity, and the pump head. Figured since I'm calculating pump head for the graph, might as well display it. I mean, it worked for one of the problems I was doing. Looking at these, they all match very closely to what the professor had in his solution uh, PDF that he submitted for the homework assignments. And I've checked this with a few other problems to make sure it's not specific. Let's see, yeah, we can change flow rate. Let's just do 5. See how the graph x-axis will change in length and then how that also scales with it and whatnot. Um, yeah, some other limitations with this is that, well, you can only really do it with a piping system that has a constant diameter. So if there's changes in diameters, um, probably won't be able to do it. Probably code in something for it, but not too entirely sure how to go about that. Yeah, that's about it for my project. I mean, it calculates, well, these are your outputs. There's five, gives you five outputs based on your eight inputs. I mean, I guess if you're using a smooth piping system where you don't have any roughness or no accessories for minor losses, then you just set that to zero and it'll work itself out in the equations. Yeah, that's about it for my project.